Hi guys, this is the key for numbers 6 and 7 on page 73, the assignment for last night, or yesterday's classwork, I guess. The first problem here, number 6, is showing the graphs of teaching salaries at private colleges and universities, and you're to answer the question, what does the impression does the graph create, and does the graph depict the data fairly? And if not, construct a graph that actually depicts the data fairly. So the impression I get here is that men make a lot more than women. It looks like more than twice as much because the blue bar on the right is more than twice as tall as the red bar on the left. However, this is not depicting the data fairly because one of the main, I would say one of the primary ways that people distort data, either knowingly or unknowingly, is by not zeroing the y-axis. So we're starting at 50,000, only goes up to 70,000, so we're only seeing the top $20,000 here of the rest of the data. And so if we think about starting at 0, then 20,000 out of 70,000 is only 2/7. We're only seeing the top 2/7 of the true bars. So this is not a fair graph. Just going to quickly sketch over here. If I start at 0, I need to get to 70,000, so let's go by 10,000s, 10, 20, 30, 40, 50, 60, 70. I'll save some time here. We'll just call that 70 by 10s. Women look like they're about 57,000 maybe. So women, men, 10, 20, 30, 40, 50, 7,000. Excuse me, 57,000-ish. Men are a little more than 70,000. And so you can see that starting the y-axis at 0 gives us a more fair representation of the data. Men are making more, but not as much more as is being depicted in the first graph. Okay. The second graph, similar situation. We're talking about incomes, men versus women. And there's a problem here too. It doesn't make a fair comparison because we're actually increasing 2 dimensions when we go from the smaller dollar bill on the left to the larger dollar bill on the right. And that is a no-no. I'll give you a quick example here. If I had a small square, if I increase 1 dimension only, the height, and let's say I increase it by twice as much, but I keep the width the same, then you can visualize that roughly, supposed to be exact, sorry for my bad drawing, but you can see that 2 of the smaller squares would fit into the larger rectangle. If we were to increase 2 dimensions, so we increase the width by twice as much and we increase the height by twice as much, we don't have a square that's twice as big as the first one anymore. We have a square that's 4 times as big as the first one. And so that's what's going on. That's a geometric representation or a geometric idea of a statistical concept. This is not going to work. How could we do it better? Probably a bar graph again. 37,053, make sure you start at 0, 10, 20, 30, 40, 50, 60,000. Let's go women and men again. Women are at 37, 10, 20, 30, about there, and men are at 53, about there. And you can see again that the discrepancy does not look as much as the dollar bills above. Okay, so those are 2 of the more common ways to mislead with graphical representation or graphs. Hope that helps. Talk to you soon.